In last lecture, I've shown you how to display Hello World on the LCD. Well, if all we can just show LED, Hello World on the LED, that is not very useful. And also, it's kind of limited, a small screen. The size of the screen has a limitation. We can only display 2 by 16 characters at a time, 2 rows, 16 columns. Each cell can display as a single character. So what if we got a longer message? What do we do? Well, one idea is to roll the text, and basically, you know, this is not new. I mean, if you walk on the street and then you see some of the neon signs where people display a message on some kind of board, the board has a limited size. And what do you do when you want to display a message that's long, that doesn't fit on the board as a whole? And then you can roll the text around and you can keep repeating it. So this is the idea I want to show you in this program. So first, let's design a class. I call it text roller to roll text on a LCD with a limited size. And the idea here is that we're going to control the display of 2 rows of text or more. The program is generic in the sense that it will allow you to control multiple rows and columns. That's whatever you specify. And the LCD we've got, it only supports 2 rows and 16 columns. So a couple of parameters that we want to take into consideration is the number of rows, number of columns that we need to deal with. Another parameter is about the rolling delay. So the idea of rolling the text, so from moving the text from one character at a time, let's say from right to left, there is a bit of a delay in between that change. So that is what this rolling delay is. That determines how fast you want to roll the text. And here I'm taking a millisecond value as an integer. And then for the instance variable, I'm converting this into a seconds, unit in seconds, because we're going to be using this number in the sleep function. The sleep function of the time library takes a seconds value. And then the primary interface is called the roll text. And this roll text method takes a text parameter and a rolling roll. So basically, this particular method supports rolling a single row. That's basically what it does. If you have a screen with 2 rows, then here this method allows you to roll, either the first row or the second row. And then the other row, if you have text, that will be basically static. Okay. Now, leave this line for now. I'll come back to it. So how do we, now there's obviously you can have variations here. Let's just say we want to sort of roll in the text from blank, and then we'll roll in the text from right to left. Okay. And once the text is all displayed, like the last character, it will move this from right to left of 1 character at a time until the last character is displayed. And then that also goes out of the screen from the left-hand side. And then the screen also is now at a blank again. And then the next, the first character of the message will get displayed again. So that sequence repeats. And the way to do that, this is obviously there are different ways to do it. This is one way to do it. Let's say we're going to use, of course, we're going to use a white space as a padding when it's not displaying the message, it's just displaying blank spaces. And we want to have how many blank spaces we have. So at a, in order to show a whole blank row in between displaying the characters of the message, we will have basically this many number of spaces with this operator on this string. This will repeat that space this many times. And so we have 16 columns, and then basically we have 16 spaces as padding. And then we're going to add this padding onto the beginning and also the end. This is just one way of doing it. Just to let you know, you certainly have different ways of processing it. And here, I create a new variable buffer. And that is simply just a copy of text. Now remember, text is a list of strings. And here, by the way, this type hint, I use double quotes because the Python version on the Pi 3.7 is a bit low. That's what it supports. For the higher version, then it will support the type hints without this quotes. So this is just kind of specifically for this list of strings, it needs to be quoted because the 3.7 version Python on the Pi. And so we want to create a copy of this, we'll call this a buffer. And this essentially is the entire text we want to display on the screen at that particular time. And this is going to get changed as we move the characters one at a time from right to left. And so that's kind of giving the effect of kind of rolling in. Now, we're going to have a loop here. And the way we loop here now, let's kind of ignore this range for a second. We're going to look at this. And actually, now the idea is this. We have this string S, it's padded around this row of text we want to roll, right? And the idea here is that first, let's get a portion of the text that we actually want to display on the screen, and which portion. And this portion is always going to be of size columns because I have 16 columns. Now we're going to just talk about, in our particular case, it's the 16 columns. And then you'll see this slice syntax, right? This slice of S is basically you use this the start and the stop, right? You kind of use the stop minus the start. That gives you the value, which is the columns, equals to the columns, which will be 16, always 16. And this is exactly how many characters we can display on the screen at a time. So we're gonna use this slice to always pick, kind of imagine if you have this S, right? Padding plus the message you want to display plus padding. You kind of have, let's say, imagine you're sliding your screen, your LCD, which is 16 characters wide. Imagine you're sliding it from left to right. That gives you the effect of displaying the text on LCD from right to left, rolling in from the right, and then rolls off the left side, right? So imagine that you got this text written down. Imagine this, you put this on a piece of paper, every character plus the padding, which are the spaces before and after. Then we're sliding the LCD from left to right across that string, one character at a time. So that's kind of gives you that effect of the text of rolling on the screen. All right, so kind of have that little visualization in your mind. That I hope you understand. And so we're getting a slice of that string, padded string, and we'll put that into the buffer, this particular row that we want to change. So this row, let's say, is the second row would be index number 1, for example. Let's say the first row is going to be static, okay, for the sake of argument. And then we want to actually roll the second row of text. In the second row of text, so this value here in the buffer is what we want to display, put onto this LCD. This contains all the text we want to display on the screen. You know, both lines of text. And so we keep updating the row, this particular row that we want to, the particular line we want to, you know, have that sort of animation going on. So this particular row gets updated continuously in each iteration of the loop. Okay, so we update this value. Imagine that sliding LCD on your string written down as a single line. And so we'll get a piece, a slice of that text that we want to actually display on the screen. So we'll get this updated, and then we write that buffer onto the LCD. Basically, it means that whatever is in the buffer, we're going to put that onto the LCD, right? And then we pause a little bit, okay? Use the sleep function, we'll pause for a little bit so that we can actually read what's on the screen, and then it will shift again, okay? So that goes on and on. Now, let's go back to this, the first line of this for loop. How many iterations do we need to do to actually finish a whole cycle? Finishing a cycle of displaying the message, that means starting from showing the blank, we display the first character of the message, and that rows in from right to left, right? So that first character goes on the screen first, plus all the blank spaces in front of it. And that keeps going until the last character gets displayed as the first on that screen, followed by all the blank spaces. And then even that last character goes off the screen, and the whole screen becomes all blank again, right? That would be a cycle. So that's essentially what we're doing, is that we're sliding the LCD on that string, to see with that visualization. From the very first character, we slide all the way down until the last character of the, you know, imagine if you have stoppers on both ends of the string, we'll put that LCD things on, you know, starting from the beginning, we'll slide it all the way to the end until the end meets from LCD, and it meets that stopper right there. Okay, so with that kind of visualization, yeah, really help you understand that. So that means how many times do we actually slide that LCD on the string, character at a time? This turns out to be the length of the string minus the number of columns, right? Because the size of the LCD slider is the number of columns, right? And then we use the length of the string minus the length of the LCD. And then we get the remaining, the number of characters that we actually, that's how many iterations we're gonna do to show the whole cycle of rolling text. And +1 means, because using a range function, we'll start from 0 all the way until this number -1, right? This number in the string range function, if you recall, this is the stop condition. They will not be included. It'll be this -1. So this is really what this is. So that's, but the number of times iterations is this, okay? That's how you figure out, this is really the primary, this is the key. This is really the main logic right here. Now, let's take a look at how to write the buffer to the screen, okay? And first thing we do is we'll move the cursor to reset the cursor to the very beginning. So we're going to display every character on the screen, right? The whole screen will be refreshed, essentially. Then we're going to process this row by row. So we'll process it row by row, and then first we're going to basically write, we just simply use the write string method of the LCD object. And what is the string we're trying to write? So here we're using this row is the line. Actually, perhaps a line is a better word here, but again, row or line, they're the same thing. And we're calling this left justified. We're making that left justified string and filled in with the spaces by default. So that means the text is going to be displayed from the beginning. And then follow that with the spaces as a filler. And once we do that, now remember though, the text, if the text is longer, right? Let's suppose whatever you pass in the buffer, you can, this just makes this more reliable. If the text is longer than what can be displayed, we're gonna basically truncate it. This is how we truncate, right? From 0 to columns. So basically we're gonna only fetch the first, the first column size text that can be displayed on the screen. If you have more text, that simply will be dropped off. So now this is kind of not assuming whether your buffer contains text that can only be displayed with the proper size. This is saying if you got longer than what I can display, I'm simply just drop the remaining characters. And then after that, we're gonna just add a new line. This is CRLF. We'll add a new line. We'll break into the next line as we print this buffer line by line. Okay, so although our screen has 2 lines, some screens are going to even support 4 lines, right? So we're going to just add a new line, and then imagine you have a cursor, like you're writing on a Word document, right? We're going to start a new line. So this is what this will do. This is simply writing the buffer, all the rows onto the screen. And then now back to explain this line 14. Line 14 here is to say we're trying to clean up the text so that it can be properly displayed as a single line. Because if the text, each line of text, what if it contains new line characters? It would not be good if it contains new line characters, because this screen has limited lines, and we don't want this line just going to break off so we want a very precise handling of the line. So this particular will handle in one line. For every line, we need to clean up the new lines. Okay, so an example usage here, when we call a row text, let's say we want to display these 2 lines of messages, and this is the first line, which will be static. Second line, we're using a triple quoted string here, which is multiple lines. And so the processing of a cleanup involves removing the new lines, so that we're going to put that back into a single line, and also remove this indentation now, because the indentation otherwise has a bunch of empty spaces. We're just not going to display them. Okay, so that's what the cleanup process will do. The cleanup process basically, here you see a list comprehension. In the basic review, I did not explain list comprehension. I suppose if you've taken that course on Python, you should have already studied that. So let's just quickly review this. The syntax is basically you're going through a loop within this square brackets. So your result is going to be a list. So we're transforming a list into another. And the text list, we're looping through it, and each time we're going to have assigned the item as a variable. So let's say we'll call it S, and we're going to process that S And then this processing of S becomes the resulting item, the transformed item. And then that will become that particular item in the new list. So the transformation here we're doing is, first, we're using the text wrap library. The text wrap library has this dedent function. Dedent function will remove the leading white space from every line in the text. That's exactly what we want to hear. So we have indentation, we want to dedent the leading white spaces. And also we're going to remove the new lines by using this replace function here. And replace this \n as a new line with actually a single empty space, because the dedent is going to also collapse all the white spaces, actually just completely remove them. When we remove the new line, we want to replace the new line with a single space. So this comes back into a single sentence with the proper spacing. So that's the cleanup text. Now, if you notice, these are private methods. The only public one is a row text. That's really the interface of the class. So what's what you use this for. Now, the main function that we're using to test. So as before, this is how we create an LCD object. And here we're going to create a text roller object. We pass that LCD object here. And also the rows and columns, and those things are used in the processing here potentially. In fact, the rows actually might not be used. Actually the rows are kind of not necessarily used, but again, that can be omitted, by the way. But now, if we're going to write a robust program, by the way, this will be probably used to verify that the text that passed in only has that number of rows we're trying to deal with. That's, as an example, usage here. So that's an enhancement here. I'll leave you to that as an exercise. How do you, let's say the text will pass in, let's say, well, I pass in as a 4, let's say I pass 4 items in this list. Obviously, the choice here, this text roller could be a little more robust, but first of all, either just only take the first 2 rows based on whatever you pass in initially, or you can simply just let's say reject it, throw an exception, say there's an error, this is not acceptable. So that's typically, this is why this would be used in a way, although here in this sort of a bare bones program I did not use it here. Okay, so that's why it can be necessary, even though it's not in this particular program, but you can enhance it. Now here we're just going to have a infinite loop here, just keep running the text, and then we're going to exit the program by hit the keyboard with a Control-C. Just, this is a terminal program. With hitting Control-C, it will exit that program. It will essentially just stop it. And so that's what we want to do. We want to just keep that text rolling. And so now here, we simply just call this row text method with passing in the text, which is a list of strings. In our case, we support 2 rows, and we're going to have 2 messages in here. And the first one is going to be static. Then say we're going to pass in number 1 here as the row we want to roll, okay, as the line we want to roll. And this is the one we want to roll, okay, it's a long, and so we actually need to roll it. Otherwise, we cannot see the whole message on the screen. And so it's 0-based. Of course, you're going to pass 1. Now, usability purposes, you can obviously turn this into 2, and then you adjust it in the method. It's unnecessary since we're running the program really with any programming. The index it's usually 0-based, and just that's the convention. There's no need to sort of full profit. Okay, so then in the if we're gonna just run this as a script, and then this module becomes a main, and so this will execute, and then here we'll invoke main. Now we'll do a little different here. We're using a try except syntax here. Try except is a way of exception handling in Python. And the except will take a type of the exception it's trying, this particular clause needs to handle. And so here, the way we're handling it is by not doing anything. Now this ellipsis here, ellipsis is, by the way, is a constant object, is defined, you know, by Python. This is part of the Python core, and it has a similar, in this particular usage, this ellipsis has multiple usages, by the way. For example, in the argument list, and this over here is equivalent to that pass that you may be more familiar with. And the newer programs typically will use this ... the ellipsis. It just seems just more, it looks more nicer. That's kind of just nowadays, it's more preferable to pass. There's no more need for pass anymore. This ellipsis is a relatively newer feature, okay? So I've explained what this program does, and let's actually run this right now. Let me switch the screen, and I have this already put onto the Pi, and they already know how to do this. So I'm not gonna need to show you how this thing runs on the Pi anymore, right? This is always the same. And I'm going to simply run. So right now I got my screen, my camera close enough to that LCD. So actually I can show you the text on the LCD screen. And I'm gonna just run this now. So you'll see the first row message is static, it doesn't change. And then the second row is the text, the long text that's rolling in. And you know, that particular message actually reads this. This is from the Wikipedia. This is actually the type of the screen LCD the controller supports. This is saying the Hitachi HD 44780 LCD controller is a now this is finished, by the way, so 1980s, that's where it ends. Now I have a blank screen and it starts again. This is the second cycle, right? Then the Hitachi HD 44780 LCD controller is an alphanumeric dot matrix liquid crystal display, parentheses LCD controller developed by Hitachi in the 1980s. So this simply just has a text explaining the history, what this type of LCD screen is. And then so the core chip controlling the screen is that Hitachi HD 44780 LCD controller. So now you may have noticed there's a shadow, right? Whenever we're shifting the character by one, and then the older character that was there for a little bit more time as a shadow. And so this is the limitation of the screen. We are controlling this, you know, sort of a character by character, and there is not very, obviously not as modern as what you would use on your cell phone, right? This is a kind of a very low cost screen for our purposes. This is sufficient. Now, if you in the early days of a messenger, there was if you, any of you have used, you know, I guess not, you guys are kind of young. In the old days, there was a thing called a pager. The pager has a screen of just this size, basically. And then it displays text, and the text would be rolling to show what the text is sent to you. So you can think of this like, you know, you can send and receive a text message. Well, actually, it's only for receiving a message. There's not even a keyboard to type in the message. I think that device was basically for receiving a message. I think that's what pager in the older days, that's how it was used. So, and this is going to be useful in your projects. Now, if you got, you know, messages that you need to display, then you basically can display this way in full, whatever that text message might be. And of course, you would need to, in your general program, you to accommodate for the time this needs to take to finish displaying before you change this to something else, for example, okay? And there's one more parameter. Now let me stop this, going back to the program. So now, because that the try except, so when you use the keyboard to exit out of the program, it's going to actually throw an exception called keyboard interrupt. So here we'll simply just ignore it. If you don't do the try except here, and then on the terminal, it's going to show exception that's not handled, and it will come as an error. So this will make it a clean exit without showing an error. Now, I wanted to show you, what did I want to show you? The rolling delay. As I said, I went over, we shifted the character, the string by a single character, and then we do a little bit of delay so you can, you can see that thing in action. You can read this. So that rolling delay, you can adjust that and play with it. You want to display the text faster, then you would decrease the delay. If you want to roll it slower, and then you just increase the delay. Okay, so you can play around that a little bit if you want. So this is what I wanted to show you, and in your upcoming lab, I'll be asking you to make some enhancements to this. Okay. Try to understand this program. If any questions, let me know.